This lecture is on performing solution exercise involving concentration units. A solution concentration can provide the relative amount of solid to solvent ratio in the mixture, and there are different units that can be used to express this ratio. The concentration units to be studied are 1 molarity, 2 mass percent, 3 parts per mass, 4 volume percent, 5 mole fraction, 6 thermality, 7 molality. Molarity is a concentration unit expressed as a ratio between solid to solution as defined by the following equation. Molarity, or capital M, equals moles of solid divided by volume of solution in liters. An example involving molarity is this problem. 3.46 grams of copper 2 nitrate is dissolved in 250 ml of water. Calculate the molarity of this solution. It is given that the mass of copper 2 nitrate is 3.46 grams and the volume of the solution is 250.0 ml, which is equivalent to 0.2500 liters. One needs the molar mass of copper 2 nitrate, which is 187.6 grams per mole, and the equation of molarity, which equals moles of solid over liters of solution. Using the solution map, start with mass of copper 2 nitrate, converting to moles of copper 2 nitrate, and dividing by the total volume of the solution to calculate the molarity of the solution. After inserting all the values in the equation, the molarity is 0.0738 m, or 0.0738 mole divided by L. Mass percent is a ratio of masses as defined by the following equation. Mass percent equals mass of solid divided by mass of solution times 100%. An example involving mass percent is this problem. Calculate the mass percent of a sodium chloride solution comprised of 3.76 g of sodium chloride in 160.0 grams of water. It is given that the mass of sodium chloride as a solid is 3.76 g and the mass of water as a solvent is 160.0 g. One needs the total mass of solution, which is by adding the mass of solid and solvent, which is 163.76 g. In addition, we need the equation for mass percent, which is mass of solid over mass of the solution times 100%. Using the solution map, we take the mass of NaCl, which is then divided by the mass of the solution, and determine the mass percent of NaCl after multiplying the ratio by 100%. After inserting the values in the mass percent equation, it equals 2.26%. In advanced concentration that involve ratio of masses as defined by the following equation, mass of solid divided by mass of solution times the multiplication factor, we have ppm, or parts per million, which has a multiplication factor of 10 to the 6, ppb, or parts per billion, which has the multiplication factor of 10 to the 9, and ppt, or parts per trillion, which has a multiplication factor of 10 to the 12th. Volume percent is a ratio of volumes as defined by the following equation. Volume percent equals volume of solid divided by volume of solution times 100%. An example of volume percent is, what is the volume percent of toluene in a solution made by mixing 40.0 ml of toluene with 75.0 ml of benzene? Given the volume of toluene is 40.0 ml, volume of benzene is 75.0 ml. One needs the volume of the solution and the equation of volume percent. Using the solution map, take volume of solid, divide by volume of solution times 100% to get volume percent. After inserting the values, the final answer is 34.8%. In advanced concentrations that involve ratio of volumes as defined by the following equation, it is volume of solid divided by volume of solution times multiplication factor. We have ppm, or parts per million, which has a multiplication factor of 10 to the 6, ppb, or parts per billion, which has a multiplication factor of 10 to the 9, and ppt, or parts per trillion, which has a multiplication factor of 10 to the 12. Mole fraction is a concentration unit that can be expressed by amount in moles by a unit known as mole fraction, which is the following equation. Mole fraction equation is moles of solid divided by the moles of the solution. The mole fractions percent is equal to the mole fraction of the solid times 100%. Normality is a concentration unit that is defined by the following equation. Normality, or N, equals the number of equivalences divided by the volume of the solution in L. An example of a normality problem is, what is the normality of a solution containing 0.275 G of Na3PO4 in 500.0 ml of solution? It is given that the mass of sodium phosphate is 0.275 G and the volume of the solution is 500.0 ml, which is 0.5 thousand L. What is needed is the number of equivalents in the sample, and since there are 3 moles of Na plus ions, which equals 1 mole PO4 3 minus ions, or 3 equivalences in 1 mole of sodium phosphate. One also needs the equation for normality, and the molar mass of sodium phosphate, which is 163.9 grams per mole. Using the solution map, one starts with the mass of sodium phosphate and divide it by the molar mass of sodium phosphate to get moles of sodium phosphate. We get the normality by taking the moles times the known equivalents in the sample and divide by the volume of the solution in L. After plugging in the numbers in the equation, the answer is 0.0100 N, or 0.0100 EQ per L. Molality is a concentration unit that is defined by the following equation. Molality, or italic M, equals the amount of solid in moles divided by the mass of the solvent in kilograms. An example of a molality problem is, what is the molality of a solution prepared from 0.225 G of glucose, or C6H12O6, in 5.00 ml of ethanol, whose density is 0.789 G per ml. It is given that the mass of glucose is 0.225 G and the volume of ethanol solution is 5.00 ml, with a density of 0.789 G per ml. One needs the molar mass of glucose, which is 180.2 G per mole, and the equation of molality as shown here. Using the solution map, we start with the mass of glucose and divide by the molar mass of glucose to get moles of glucose, and then divide by the mass of the solvent in kg to get molality. After plugging in the numbers, the molality is 3.17 m, or 3.17 mole per kg. Here are some review exercises for you to work on. Please solve each of the following problems. Answer each to the appropriate number of SFs. A. How many ml of water are required to dissolve 25.0 G of urea in order to produce a solution that is 1.65 m, or 1.65 mole over kg? B. What is the volume percent of 10.0 G of acetone in 1.55 L of an acetone water solution? C. Calculate the molarity of 0.4237 G of KHP, or potassium hydrogen phthalate, in 100.0 ml of solution. For the remaining part of this lecture are solutions to review exercise or problems. Please view only after completing these exercises.